All right, let's do another problem. Here's your challenge. Same process, different network. You've been given 10.0.0.0/24 network. You need to subnet it into 4 networks. First network, we need 100 hosts. Subnet 2, 50 hosts. Subnet 3, 25 hosts. And subnet 4, 2 hosts. Pause right now. Sort these out from largest to smallest. Find your subnet masks. Find your network IDs. I'll wait. Go ahead and pause the video. Come back and we'll see how you've done. All right, let's check how you did here with the process. I'm going to do mine a little bit differently this time, and I'm going to lay out all of my network IDs first, and then I'm going to fill in the rest of the table. If you take a look at subnet 1, we need 100 hosts. For 100 hosts, 2 to the power of h minus 2 will need to be 2 to the power of 7. That will give us 2 to the power of h minus 2, which equals 126. That definitely meets our 100 hosts requirement that we have here. So we can calculate this out looking at our subnet mask. We need 7 host bits. With 7 host bits, we end up with 1 network bit. This converts from a binary to decimal value of 128. In our interesting octet here with 128, we will subtract 128 from 256. Then we get 128. 128 is our block size. We'll add it to 0 in our interesting octet. So our next network ID is 10.0.0.128. All right, now we're just going to move on to subnet 2 here. Subnet 2 requires 50 hosts. 2 to the power of 6 equals 64. 64 minus 2 equals 62, which meets our 50 hosts requirement. The 6 here in this formula lets us know that we need 6 host bits. So we need 1, 2, 3, 4, 5, 6 host bits, which leaves us with 2 network bits. If we convert our 2 network bits here into a decimal value, that is 192. So our subnet mask is 255.255.255.192. We can calculate our block size. 256 minus 192, 64. With a block size of 64, we add that to our interesting octet up here at 10.0.0.128. When you add 64 to 128, you end up with 192. So subnet 3's network ID is 10.0.0.192. All right, in subnet 3, we have a requirement of 25 hosts. We can meet that with 2 to the power of 5 minus 2, which will end up equaling 30. That meets our host requirement of 25. We need 5 host bits in our subnet mask. So if we put in our 5 host bits, and that means the remaining 3 will be network bits. We can calculate our binary value here with the 3 host bits into 224. So our subnet mask for subnet 3 will be 255.255.255.224. Now we can calculate our block size. 256 minus 224 is 32. When we add 32 to our interesting octet of 192, we end up with the value 224. So our 4th subnet will have the network ID of 10.0.0.224. Now I don't need a 5th network, but I'll use this 5th network calculation to get my broadcast ID for the 4th subnet. I know that in the 4th subnet, I need 2 hosts. 2 to the power of h minus 2 gives me a value of 2 to the power of 2, which equals 4. 4 minus 2 is 2. I'll need 2 host bits, and then I fill in the remaining with 1s. When I calculate this binary value to a decimal value, I end up with the value of 252. 256 minus 252 equals 4, so my block size is 4 for the 4th network. I add 4 to my interesting octet in the network ID, and that gives me the value of .228. So .228 would be the network ID for a fifth subnet if I had one. Quick pause here. If you've been following my videos all the way through this subnetting series, I'd really appreciate a comment to let me know what parts you found the most challenging or the most helpful, because getting feedback from you is how I become better at making videos. And I like making these videos and helping you with your CCNA. So that would be great if you do that for me. Now I can just go back through and subtract 1 from each network ID and get the broadcast IPv4 address. We can do that here real quickly. 228 minus 1 equals 227. Looking at our fourth network, 224 minus 1 equals 223. That goes here in subnet 3. All right, now we'll subtract 1 from 192. That gives us 10.0.0.191 for subnet 2's broadcast IPv4 address. In subnet 2 here, we'll look at the network ID of 128, subtract 1. That gives us our broadcast IPv4 address for subnet 1 of 10.0.0.127. Here we can see our full range of each subnet. Then we just add 1 for the first network ID, and we subtract 1 from our broadcast IPv4 address to get our last usable IP address. How did you do? If any step tripped you up, you can rewind to that section and rewatch. Or maybe go back to one of the previous videos if you now realize that you might have skipped an important step. You need to master each step along the way in subnetting, or it becomes very difficult when the problems increase in complexity. So it may seem really simple at first when you're subnetting by equal number of hosts or equal number of networks. Now we're really getting into subnetting here, and if you haven't mastered all of those steps, you're going to notice it right away. So go back, master all of the steps, and then come back here and see if you can solve the problems. If you've been following this series from the beginning and you're mastering this process, you're almost there. You've mastered VLSM, which is one of the hardest parts that students tell me. It's one of the hardest parts of the CCNA, and it's what holds a lot of people back from taking the exam. I hope that's not you. In our next video, we're going to be subnetting in the 3rd and 4th octets. So we're going to be going up a bit. It's not technically part of the CCNA, but having taken the CCNA, I can tell you that there are questions where you don't exactly have to subnet in the 3rd octet, but you've got to understand if your network is not working properly. So they do subnet in the 3rd octet, and you're expected to notice that there's a problem there. So we'll be moving on to that in the next video. All right, thanks for watching. I hope you learned something today. You look like you learned something today, and that makes me really happy. I hope to see you in the next video. Bye-bye.